Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue looking at this fun little problem of formatting a big integer with ellipses in the middle so you don't print out the whole thing, and this one approach that somebody posted and saying, hey, maybe check that one out. So that's what I'm about to do. Okay. So we have a very simplistic way of doing it. Let me get rid of these metadata things here because that's just confusing stuff. And eventually I have to make sure that I am printing out the that to do precondition desired length has to be greater than or equal to, otherwise it doesn't make any sense. Okay, so what happens if we go the route that the other person suggested? Okay, so we're going to say public. Pause there for a second. String get string length length optimized big integer value int desired length. Okay. Yes, you're not doing anything because we're saying there's a to do here. Okay. So same thing here. We need to, well, why am I saying int var? I don't have my handy dandy editor configure that would flag that. That's why that wasn't happening. And because I just did a console F4 because why not? So, okay, we want to get the number of digits. Okay. If the number of digits is less than the else, okay, then we're going to do the fun stuff. Fun stuff happens here. Okay. So again, if we know that we've asked for 20 digits and the number is only 10, just two-string it. Simple, okay? But if you only want 20 digits to be printed out, the number is 2000, then you have to drop into the optimized way of doing it, okay? Let's kill this because I don't need any of this, okay? So the chars before and the chars after are what we're calling our remaining length. Okay, so we want to capture this. That is the same because we still need to figure out what the left side length and the right side length is. Okay, but that's kind of what the chars before and chars after are. Okay, now it's going to get a little bit more try. And then we need a finally because we need to return the rented buffer. Okay. Now we don't have to worry about this because we're never going to hit this exception. The temp buffer that we're going to make here, we're going to call this var format buffer. I don't like the word here. Format buffer is nope. I don't know what you just did, but don't do that. Okay. And what we want to rent out here is an array of remaining length. Okay. No. Desired length. There we go. Okay. And when we return it, I'm going to have to do one thing here, which is I want to actually format buffer there. I do want to zero it out. Okay. Or do I? I don't know. I think if I know that I'm saying I want an array of 100 characters and I'm going to fill out just those 100 characters, if the rest of it's garbage, what are they doing when they're printing this out? Original. Yeah, I don't know if that's actually... I want to be safe here than sorry. Okay. And I know that probably adds a little bit of a perf hit because you're basically saying clear the array, but I want to make sure it's all zeros in it. Okay. All right. So what we're going to do is create a string here. Let's just copy this. Okay. Okay. Can you say private const and ellipses length and just say testing string formats ellipses dot length? Is it going to be able to let you do that? Well, not if I don't spell it wrong, but it's probably saying, yeah. But what I can say here is static read only. Okay. So whatever that gets to be. And then we can just optimize because we know it's always going to be that. So the string we want to create this as the, what are we calling it up here? No, down here. The output. Okay. The output. And that's actually what we're going to return once we get out of this mess. Return output. Okay. The chars before dots is the left side length. The dots length is tsf.el. This is right side length. Okay. This is our format buffer. What was length here? That was the TryFormat. Remember, Jason, you need to do BigInteger format. Oh, there is no. Where is that coming from? Okay, it's what? Hold up. I'm a little confused here, which is not surprising. What is TryFormat? It is a... Oh, I'm being a moron. Value.TryFormat. Okay. And we want to pass in the format buffer of our, we don't care. I know I'm making some bad assumptions here potentially, which is saying this should not happen, but we're saying this, ooh. Oh, ouch. No. This is the number of digits. We have to do this, okay? This is why I want to do this, because it might just, since you have to get all the characters anyway for the value, TryFormat, the only thing that this might give is that you're doing an array rent. And that might be actually more performant because you don't have to do any allocations as you do this more often, potentially. I don't know. We'll see. Okay, so the length here is what? The temp buffer was, oh, it is the length of what you did. And since we know what it is, we don't need to assign it though. Right, but we do need to pass it in here. Okay, that's what we do need to do. Okay, so the original, I guess, is that. Yes, span. Do you know what that is? Yes, you do. Okay, state.length. The length was what, because it was being called here. Okay. Yeah, okay. So chars before dots is left side length. Dots length is TSF dot ellipse length, and this is right side length. And you don't like this because these are static. Operator that can not be applied to both. Well, that's length. That can't be captured? Yes, because chars before dots can be captured. There. I guess like, yeah, you have to figure them out dynamically. We can't say what the chars before and after should be. So, okay, whatever. If the original length is less than that, then we just copy the whole thing into the buffer. But why would we do this? We would never get to this part, right? And what I don't understand either is that this is a char format buffer. Oh, it's because it's an array pool, yes, and we put that and that. And so we need to span it. But this is something I shouldn't need to do, because I'm assuming we only get in here if we know that our length is, you know, we do the else here. So this is left side length, left side length. What? Thank you. It was weird that it wouldn't. Now this is TSF, ellipses, as span, copy to, chars before dots. That. This is right side length. That. Okay, so now let's do the same thing here. Comment this. And now let's do this, except let's do it as optimized. Right? And the thing we don't really care about is if you ever get to be like the desired length, like the number you give is smaller, because in both cases it's literally just going to print the same thing out and there's no difference in approach. Okay. All right. Let's see what we get in these cases. 4, 7, 6 looks the same. Looks the same. Okay. Now what we need to do is look up benchmark .NET because I can never remember. Oh, well, because I look at it so much, this is what I needed. We're not going to be able to use the attribute route because we can't constant a big integer. And I don't want to put a string in there and take the hit of doing a format of the big integer. I want to do that in the data that's being output. So yeah, here's the source. So yeah, this one is taking a double and double, but you're doing an object. I wish they wouldn't do this, but that's okay. All right, so what we want here is a values. Yeah. Okay. Except what we want to yield here is like a big integer dot parse. We do 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And let's do like 20. And what we want is a desired length of 10. And that is like that. Okay. Now, let's change this back to int. So we're going to get the length. And again, I may be looking at this later and going, wow, there was a huge bug here, you know, and that will be shored up later. This is just kind of proving out, does this actually have any worth to it, or is it just simply good just to get the string and chop each end off of it? Because that's what you're going to do anyway. So that's a 20-digit one. Let's do a 20-digit one where the desired length is 50, because in that case, no, we want to avoid that, because we know in both cases that's not what we're going to do. Okay. So we want to say that's a 20 and we want to get a 10 out of it. Okay. So this is now a, let's do a 40. Well, wait, that was 20. That's 40. And let's do it as a 15. I'm just throwing numbers out here, okay? This is an 80, and let's say 33, okay? And now let's do an 80, 160, 240, 320, whatever that is. And we're going to say 15, okay? And so now when this runs, which we're going to have to do in release mode, okay? So now when this runs, what we should see is a comparison between the two, except what else we have to do? We have to say the argument source, okay? So this is a benchmark. Baseline is equal baseline is equal to, oh God, true. Except we also want to say the argument source is the name of testing string formats values, okay? Same thing here, except we don't want the baseline on the unoptimized one. But we do want it to get the same data, okay? And then we come back over here and we comment all this out. Except what we're going to do is benchmark runner dot run testing string formats, which of course you don't know what that is, do you? I do. It's right here. Okay. Now again, this is not an exhaustive proof by any stretch of the imagination. Okay. Even if this shows some promise, I would go off and do more testing, and then maybe when I get back from my vacation, I'll show the results, because then I need to go back. One thing I forgot to mention in the previous episode is that whole AutoWeave compiler program idea that I had. I'm not going to forget that. I have it. I will get back to that. My whole intent, was last week is to get something working, and that just never happened. But I at least want to get to the point that I'm going to show that it will do all of the diagnostics and all of the analyzers and all of the code fixes in one fell swoop on a tree. Okay. That's not going away. So we're going to try to check that out later. But time, vacation, and all that other good stuff. Okay, so now what this should do, let's just check this out again, is you'll pass in a big integer and a desired length, and we should see these two being compared. Okay, so that's interesting that up here it doesn't say, you don't need to do anything with it, but down here it's saying unnecessary assignment. I don't know why. I don't understand why. I'm going to give this a whirl. I'm going to let this run, and when it's done, I will come back and we'll talk about the results. All right, here we go. All right, results are in. You ready to see them? Are you going to be shocked? I don't know. Maybe you won't be. But here's what at least this run produced. Okay. So what I also find interesting is benchmark.net is also doing something here to say, well, you need to print out 40 numbers. It's already doing something like this, which I think is kind of funny. I'd be interested this, now that I think about it, benchmark.net has to be doing something here to say, well, that is the length of the whole thing. This is what you printed out. And actually, you could argue and say that's what you'd almost want to print out, is something like that. Say it was 40 digits total, 80 digits total, and then it always evens it out either side. It just says, that, and then it puts maybe not the dots here. So this is a side note that I'm also going to want to find out, what does benchmark.net do? Where in its code does it actually, and this is open source, I got to be able to find this somewhere. So I'd be curious to see what they do. But what is done here is this. The optimize, when the number of digits is small, really isn't a big gain. Okay. It's always better from a memory consumption standpoint. Okay, it's always going to do a little bit less memory. Okay. When you get to 320 digits, you notice you just do 1008. Here you're doing 1.6K. So that renting of the array, I'm guessing is what's, what you're trying to do here. And in fact, I didn't say that right. The renting and return of the array is causing less memory to be allocated. But again, you have to do the whole thing anyway, because you have to put it into a char buffer here to format it. So you're essentially making a string, more or less. So the only thing that is gained is that you share an array that you don't have to keep potentially doing some allocations with actually doing it as a string. I don't know. I'm guessing maybe that's where the benefit is coming into. The original, that's just the format buffer that you passed in as span, which is the start and the length. The original you're copying into the buffer that is going to be the output, because that is a span. And I believe because you're passing in this amount, it's also creating something that's going to be a span to say you can only have that much, I'm guessing. Then you copy in for the left side length past it, right side length past it, I think, up to whatever. And then you copy 2 into the original. And the original is what actually makes the output, and that's what you print out. Okay. So it does seem to help as the numbers get bigger. But of course, how would you know on the fly which approach you should take? Is there a better way to do this? It would be nice if there was a way for BigInteger to kind of stream out the numbers that's giving, but you want to get the ends anyway. So you have to do the whole thing. Obviously, if you wanted to really optimize it, the crossover point seems to be, I would say, right around 80, because that's where at least here it started to show a slight bit of improvement. But the memory allocation always seems better, slightly better. So you're going to be saving on memory. The one thing, again, I want to look at is to say with benchmark.net itself, when it's formatting a BigInteger, it's doing something very close to what we want anyway. And what is it doing and how optimized is that? So that's something I'm going to look at later on. So I'm not going to be throwing this into Spackle just yet because I'm not entirely comfortable with what this optimized approach takes. I'm not really sure if it's, exactly what we need to do. And maybe you say if you're under 64 characters or something like that, then just doing a 2-string and the concatenation is probably going to be fast enough. Whereas you start going above that, you need to do something a little bit more tricky so you can save on memory, or performance. Though, yeah, around 80 is right when you're about to cross the crossover. I was reading the 2 wrong. Right, that's when you're about to cross over, and it'd be interesting to see how far more you got. So that's 2 things I need to look at: is what does benchmark.net do? And is there any way to make this even faster? I'm not sure. Based on what you can do with BigInteger, I don't think you really have much of a choice, because 2-string just 2 strings it and gives you a string. TryFormat basically gives you what 2-string would do, except it puts in a char array. And, yeah. So, and I'd like to see what happens when you get up to 500 characters and 1,000 and 5,000 and 10,000. How much does this really start to benefit? So that's all I'm going to do for right now, though. I might come back to this later, and if I think it's worth it to put in as a helper function to Spackle.net, I will do so. But yeah, for now, I'm going to just let this rest and enjoy the rest of my vacation. So thank you all for watching. Leave comments and questions below. See you in the next episode.